Let us start with the module 2. The module 2 consists of inverter and other system component. We already know that PV arrays or PV models are required to produce electricity, but there are many other equipments which are associated with the PV modules to convert electricity from DC to AC. So PV models or PV arrays or PV cells, they produces only DC supply. So when your equipment is operating, when you are using the equipment, that time you require the AC supply. So conversion of DC to AC is very important. For that one, we are using other equipments like inverter, PV combiner boxes, and meter and the meters. That is meter we are using. You can see this diagram. This one is a diagram. In this diagram, if you see PV array or PV cell is there, it is given to the PV combine box. Then it goes to the grid interactive inverter. Okay, that is grid interactive inverter is there. In this grid interactive inverter, what happens? This converts the supply and gives to the give it to the particular grid. And import export meter is also there. So when it is required, and another 2 points load points are there inside the house. If required, they use the supply, and if it is excess, it will be given to the grid. There is another one system in this, the alternate method. So this one, what happens? PV arrays, it produces electricity, give to the interactive inverter. From there, it goes to the grid. Now after giving the grid, it passes through the meter, that is import meter. It is called as import export meter or net metering it is called, where supply where the count, or where the supply, incoming supply and outgoing supply is considered for that one. Now let us move towards the inverter. The inverter, what happens? A photo array produces DC. So the grid operates on AC. So the inverter converts DC into AC supply, and it is made to flow to the grid. So designing it is made in such a way that it converts the DC supply into AC supply, where it is having a switching mechanism. So there are two types of inverter. One is battery or power inverter, which is used in the houses, and another one is grid interactive inverter, which is connected to the grid. Battery inverter, we all very know, we are familiar with this one. We use it in the car, or we use it in the house, where the inverter is there. PVC cell inverter battery is there. From PVC cell DC is there, inverter converted to DC to AC, then it is battery stored into the battery. uh, it is converted. First it is taken from PVC array, DC supply. DC supply is stored in DC batteries. Then inverters are there, which takes the supply and convert from DC to AC and give it to the load. So this type of battery, it is used everywhere. It is of 1 kilowatt to 5 kilowatt, whereas it is having different functions also. Now grid interactive inverter. In grid interactive inverter, it is a quite different type of inverter. It is not a normal inverter. It is used particularly to send the supply to the grid, and it operates when it is connected to the grid. If it is connected to the grid, then only they will operate. But so it is called as a grid tied inverter. Grid tied, it also convert DC to AC, but the frequency, range of frequency and voltage, it will be matching with the grid. And this is having many functions, interactive functions. So let us go one by one the functions. Connect DC power, from there it converts to AC, and it is can be used. It can give to the particular site also. It can give it to the grid also. It give to the grid. Ensure that the power being fed into the grid with proper frequency and proper voltage, it is given to the grid. If it is not connected, the frequency and voltage are not matching, then it will not work. It uses the maximum point tracking system to convert DC to AC. And my softwares, inbuilt softwares are there, and many, which helps in conversion, or which helps in proper functioning, and safety precaution also are there in this one. So many A grid interactive inverter may be different from other in different way. Whether or not the inverter has maybe they might be have transformers, they don't have transformers. Switching frequency is there. Switching frequency and voltage frequency is very important here. And so there are many different type of function for the grid inverter. Now let us say about the transformer. Transformer, it is a device which increases or decreases the voltage. So traditionally, when the inverter is there, with inverter transformer should be there. Transformer should be there. So this is the testing, an electrician testing a grid inverter, grid interactive inverter. So there are many types of things are there in this one. Now there are many ways of the technology has improved, and after improvement of a technology there is transformer less inverters also are used in this one, and the main problem in this one, transformer with inverter it is very good, because what happens, there is the isolation of a circuit and DC current cannot be transferred to the grid. But if it is a transformer less inverter, then the problem what happens, the small amount of a DC power, it is a transformed to the grid. You can see this is a transformer less inverter in generally. Okay, this is first point. Okay, this is inverter with transformer which is used in many location, and these are the various datas provided to procure inverters. Now let us move to this mean string inverter technology, where the inverters or strings are connected to form a combination of the inverters, and this there are many ways. For example, first what happened, the maximum power point tracking. This is very important. If you see, this is the maximum power point tracking is means the maximum power which can be obtained at particular point. PMP, the PMP which they show, it is the maximum power point which they are taking. So there are many points in the line or in the graph what they have shown. There are many points based upon the requirement, based upon the requirement. The MPPT is considered and taken in this one. So the first string inverter, in this inverter you can see the number of strings are there. Strings are used in small ranges from 1 kilowatt 1 kilowatt to 11 kilowatt, where it is a combined and it is a form. So this is a string inverter. So next, there is various form it is a possible. Here also it is called as possible multiple string. It is called as a multiple string across the same string node. Number of strings are connected, so it form multiple string. And here also you can see here the multiple inverter can be used for this also. Multiple string inverters are being used. So they uses one MPPT for that one 40%. So this here also it is a how they use multiple string inverter. This is the way they use this. And here it is a two strings. You can see the two strings and multiple string inverters they have been used for this purpose. So centralized means centralized. If you see the central inverter, it is similar to string inverter with multiple strings. Here multiple, again the multiple strings are connected to only one inverter. Only one inverter it is connected, then it is given to the switchboard, then it goes to the grid system. So in this way, when you connect number of strings or PV models, the output, the DC voltage goes on increasing, and depending, it is fit to only one inverter which convert from DC to EAC. This is the it is used in one of the area. Modular inverter is also known as a micro inverter. It is a small transformer-less inverter, and it is placed at the back of the PVC panel. Before what, in many types of model inverter has come, but this is one of the important modular. It is having a two advantages, that long cable, no need of using the transformer, and long cable is not required for this one. And for handling also it is very small. It can be handled very well, and the cost also is very less for this one. The and you can see this is the inverter modular inverter. It is mounted at the back, particular at the back of the panel. But the main disadvantage of this one is that it is placed behind the PVC panel. So what happen, the temperature or the heat temperature increases and affects the performance of the modular inverter. So it might the operating condition might be different, and if the temperature starts increasing, then there are more chances that the inverter might fail. And if it will, and the designing will differ from for the hot season and for the cold season. Protection, inverter protection system is required. Protection system is required when a grid connected inverter is there. It is having both passive mode and active mode, and it performs on some functions. So what happened, the inverter has many protection devices. It work on MPPT software, which allows the output, and it will check, which allows the PU output to be optimized to the best match the grid specification at the time of power output. It means that it matches the grid, and it is shown that what happened, it is that grid, particularly P model, and the grid frequency, voltage, other parameters are synchronized or matched, or a software is fed in that particular in the in the inverter, that it matches with the grid. So any problem occurs, it disconnected from the grid, and if all the parameters are matches, then it supplies the current from PU panels to the to the grid. So there are many self protection, like any incorrect connections are there. It will check if any incorrect connections has been made, or it might damage the PV cells. Also, temperatures plays very important role, because what happen, the inverters output performance effect with the temperature. So manufacturers or specification has to be considered, and has to be worked out to keep that inverter in proper temperature. So these are many front panel of the inverter. We can see in the front panel of the inverter many things comes, faults, various type of fault it indicates to you, and MPPT point also is very important. When any DC voltage is too high, that time what happen, it detects, the inverter detects and disconnect itself from the PV grid. And many grid protection also is very important. Grid protection, the main thing is it should disconnect when any problem occurs, any disruption occurs in the grid. That time what happen, the inverter disconnected from the grid. So anything happen when a overload is overload or under underload, voltages, frequency, anything changes occurs, then automatically the inverter removes from or changes from the disconnect from the grid. For example, number of PVC inverters are working, and any one of the pole is hit by the car. That time what happened, the frequency of the particular inverter or particular it won't matches, they may change in the variation. So that time what, cable breaks or anything happens, it automatically check with the particular grid, and that time disconnect. Before it was such things were not there. Any grid, when a grid is not working, or it is in a blackout, or any fault occurs, that time the particular PVC solar panel used to supply power to the grid. It can causes lot of problem, that it used to supply that, and that phenomena was known as islanding. So now, to it was a serious concern over this one. So what happen, if a grid is shut down, the people are working, and it is supplying, the PUC system is supplying, or the supply, then there may be there are many chances that the accident might take place. So what happened, nowadays they are taking more care to resolve these islanding issues. What they have done active and passive protection has been provided, in which the it detect the particularly the inverter, it detect the voltage and frequency of the grid. If it is a matching, if everything is okay, then only it will supply then only it will give the supply, otherwise it will won't give any supply. This is a balancing of system equipment excluding the PV panel array. Now you can see the number of things in this one equipment which comes. The equipment are cabling which are required, connectors, isolator, protection devices, monitor equipment. This all are required. You can see this one PUC model is there. PUC model, particular model is there. Now in this PUC model, you can see many key component like isolator, inverter, cabling, junction box, all things are required. If you want, this meter also is required, how it is connected there, mounting frame is there, mounting frame is there, PUC models are there. And then it is again to junction box, from junction box to cable, then it is to isolator, then inverter, then to meter also, and goes to the grid. These are the process which it was. So here they have given this how it works. DC cable is required, that they have given. Box is required, P command boxes should be connected. Modular junction box located at the back of the model, that is required. Protection device isolator such that isolators are important. Lightning surge protection, metering also is important, and cabling cable also is required to connect. Grounding cable also is required. Connected. The monitor, it is used to check what kind of any problem occurs, anything, that also it is installed.